For months, 3I Atlas was treated as a mystery that refused to behave. Astronomers labeled it anomalous. Commentators called it unprecedented. Online speculation went much further, suggesting that what we were seeing didn't fit comfortably within natural explanations at all. But now that 3I Atlas has completed its passage through the inner solar system and is fading back into interstellar space, something interesting has happened. The mystery didn't deepen, it clarified, and in the process, it became clear that almost everyone, from social media theorists to cautious scientists, was asking the wrong questions. When 3I Atlas was first detected, it was already moving too fast to belong here. Its velocity and trajectory made one thing immediately obvious. This object did not originate in our solar system. It was only the third confirmed interstellar visitor ever observed, following Oumuamua and 2I Borisov. That alone guaranteed attention. But attention quickly turned into confusion when Atlas began behaving in ways that didn't align neatly with either of its predecessors. Early observations showed a growing coma, but the chemistry didn't match expectations. Carbon dioxide dominated the outgassing, while water, the defining feature of most known comets, appeared almost absent. Even more puzzling was the geometry of the dust and gas surrounding it. Instead of forming a clean, sun-opposing tail, Atlas displayed persistent material extending toward the sun itself. An anti-tail. Something that is rare, temporary, and usually explained by viewing angle, but in this case it refused to go away. As Atlas moved closer to the sun, the behavior intensified rather than correcting itself. The anti-tail became more pronounced. Multiple jets appeared to erupt simultaneously from different regions of the object, forming structured patterns rather than chaotic plumes. High-resolution imaging revealed symmetry where none was expected. And at that point, speculation exploded. The idea that this could be an artificial object didn't come out of nowhere. It emerged because people were trying to force Atlas into familiar categories. If it wasn't a normal comet, and it didn't behave like known asteroids, then the leap to something engineered felt tempting, especially in an era where distrust, secrecy, and fragmented information dominate public discourse. But that framing missed something important. Nature doesn't owe us familiarity. When Atlas passed behind the sun for several weeks, observations paused, and during that silence, assumptions filled the gap. Many expected that when it re-emerged, it would finally reveal its true nature, one way or another. Either the strange activity would stop, proving it was just a perspective illusion, or it would escalate beyond any plausible natural explanation. What actually happened was far more instructive. When Atlas came back into view during Earth's closest observational window, instruments saw a dramatically changed object. The coma had thickened, the jets were stronger, but the chemistry had shifted. Radio spectroscopy began detecting large volumes of water vapor pouring out from beneath the surface. Not trace amounts, massive quantities, enough to rival or exceed the output of typical solar system comets of similar size. This was the moment when the narrative quietly collapsed. Because it meant the water had always been there. The reason it hadn't appeared earlier wasn't because Atlas was fundamentally different. It was because the water was buried, locked beneath a hardened exterior layer that had spent billions of years exposed to interstellar radiation. Galactic cosmic rays, moving at near-light speeds, slowly altered the chemistry of the surface, breaking apart molecules and converting lighter compounds into more volatile ones like carbon dioxide. Over unimaginable spans of time, Atlas developed something like a radiation-processed shell. A crust unlike anything we commonly see in our solar system, not because it's exotic, but because our comets don't live in deep interstellar space long enough to acquire it. When Atlas first entered the warmth of the sun, that crust began to fail unevenly. Gas escaped through weak points, pressure built, jets formed in unexpected directions. And because the internal energy release was strong enough, it could temporarily overpower solar radiation pressure, creating the illusion of a tail pointing the wrong way. Nothing about that requires intelligence. It requires patience, time on cosmic scales. As the sun continued heating the object, the crust fractured further, allowing the buried ice to finally sublimate freely. The comet we expected to see from the beginning emerged late, after confusing everyone watching from Earth. Atlas didn't transform into something else. It revealed what it had been all along. This reinterpretation explains nearly every anomaly that once fueled speculation. The triangular jet patterns are consistent with rotating bodies, venting through discrete surface fractures. The prolonged anti-tail aligns with episodic mass ejection events rather than steady sublimation. Even the early chemical imbalance makes sense when you consider surface processing versus interior composition. And importantly, this explanation didn't come from one telescope or one team. It emerged from combined data across optical imaging, infrared analysis, and radio spectroscopy. Independent instruments, independent groups, converging on the same conclusion. That includes those whose professional mandate is to rule out artificial origins. Organizations dedicated to the search for extraterrestrial intelligence monitored Atlas extensively as it passed through detection range. Radio surveys scanned for narrowband emissions. Infrared observations searched for waste heat. Nothing. No structured signals. No anomalous energy output. Nothing that even remotely resembled a technological signature. The sensitivity of these observations was sufficient to detect emissions far weaker than everyday human technology. If Atlas were transmitting, maneuvering, or operating under control, it would not have remained silent. That silence is not suspicious. It's informative. Still, some uncertainty remains, and honestly, it should. Science does not require total certainty to function. What it really needs is consistency, testability, and, the willingness to abandon dramatic explanations when simpler ones survive scrutiny. Atlas reminds us that unfamiliar does not mean artificial, and strange does not mean designed. What everyone was wrong about wasn't Atlas itself. It was actually the assumption that our existing categories were complete. Interstellar objects are not just visitors from elsewhere. They are, in a way, archives. Each one carries a record of chemical processes, radiation exposure, and dynamical histories that our own solar system can no longer preserve. We expected Atlas to behave like something born here. It wasn't. And that mismatch created confusion where, really, there should have been curiosity. As detection technology improves, objects like Atlas will become more common. Telescopes like Vera Rubin will identify them earlier, track them longer, and, observe them in greater detail. And when that happens, we will need better instincts, not for speculation, but for restraint. Because the universe is capable of producing things that look wrong until we understand the conditions that shaped them. 3. Atlas didn't challenge our understanding of physics. It challenged our expectations. And in doing so, it quietly taught us something far more important than whether we are alone. It reminded us how much we still have to learn from things that pass through our sky once, briefly, and never return.